Okay, we're looking at Logic Game 3. This is LSAT 42, December of 2003. A bakery makes exactly 3 kinds of cookie, O, P, and S. Exactly 3 batches of each kind of cookie are made each week, Monday through Friday, and each batch is made from start to finish on a single day. The following conditions apply. Okay, so what we know is that we have 5 spaces, Monday, Tuesday, Wednesday, Thursday, Friday, and that we have a total of 9 things that are going to occur. We need 3 O's, 3 P's, and 3 S's. So we have a 9 is what the total would be, okay? The following conditions apply. No 2 batches of the same cookie are made on the same day, or the same kind of cookie. So we couldn't have like all O's made on Monday, okay? At least 1 batch of cookies is made on Monday. Okay? The second batch of oatmeal cookies is made on the same day as the first batch of peanut butter cookies. So we know the second O equals when the first P occurs. And then the second batch of sugar cookies is made on Thursday. Okay, so as always, we want to apply the hierarchy of rules to solve for the scenarios. This is a fairly complex thing that will occur, but it will be solved through just simple distribution. We know that on the second S is on Thursday, so we know that S has to occur here. All right, and so if S occurs here, then we also know that the third has to be on Friday. So we can just go ahead and fill that in. All right, and now we just need to distribute where can the first S occur, okay? So the first S can occur on Monday, it can occur on Tuesday, or it can occur on Wednesday. Okay, so we're done with that. This rule is completed. All right, so the second O must equal when the first P occurs. That means that the very earliest P could actually occur is on Tuesday. All right? So what we need to do is distribute P and figure out what P can do. There are 3 P's with 4 spots. We're just doing kind of a 3-4 type of distribution. And so let's just exhaust what P can actually do. P can go all right, that's what P can do. If it's right there. Actually, I'm going to do this a little different. All right, so P can start all there, and then the last P can move over. All right, and then we can have P go all the way over. And then the last thing that can happen with P is it can be completely over there. Okay, and that is all that P can do. All right, so what we need to do is just extrapolate this over. And while it looks cumbersome, we're going to end up making 12 of these things. It's not that bad because we're not required to really think through this distribution. We're just moving variables. All right, I'm just going to place my S's. This isn't a chain reaction of any kind. We're just exhausting what all P can do. Okay, and then let's just finish it up right here. Okay, all right, so we have completed that. And now we just need to think about what O has to do. Well, anywhere where there's the first P, the second O has to be. All right, and so because that's the second O, we know that the first O, we know the placement for the first O quite a bit. Now, I forgot to put the O here. Now here we could have O, O can go either here or here, all right? Now, with regard to the first O, we know that there has to be a Monday taken up, and that's what makes O go right here. All right, we know O has to go here, 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 and there. Okay, and that's all that can occur. We know we could exhaust out what can happen with O. We know that O can go in one of three spots here. O can go here, one of three here, one of three there. One of three there, so it's just wide open what O could actually do. So we're just going to leave it be. This is a situation where this is kind of the only one where I'm going to say that it's critical that we understand that O can go here or here. But other than that, the last O just moves wherever beyond, where the second O was. So we have completed the solutions to this. 3, 4. We've created 12. I wouldn't be intimidated to create this many, where the distribution is just one of moving. We had a 3-4 distribution, and we were really told SS, and we moved 1 and 3 spots. That's just not that complicated, so we should be able to build that relatively quickly, and then this game will pretty much fall into play for us. All right, which one of the following could be a complete and accurate list of the days on which the batches of each kind of cookie are made? So if we look at the first rule, no two batches are made on the same day. Well, if you go through A through E, no answer choice violates that rule, so we go to rule number 2. At least one batch of cookies is made on Monday. Well, if we look at C, we don't have a batch of cookies made on Monday, so C falls out. If we look at rule 3, the second batch of oat milk cookies is made on the same day as the first batch of peanut butter cookies. Answer choice D puts the peanut butter cookie on Monday, so that's automatically cannot happen because the first oatmeal and the first peanut butter are on the same day. And then if you look at E, the second batch of oatmeal is on Thursday, and the first batch of peanut butter is on Tuesday, so that rule, so that answer choice is eliminated by the rule. So we're only looking at A and B, and if you look at this rule, it's the second S is on Thursday, and if you look at B, the second S is actually on Wednesday. So A is the correct answer to this analytical, or to this question. All right, let's look at 14. How many of the days, Monday through Friday, are such that at most 2 batches of cookies could be made on that day? All right, well, if we look at Monday, we know that the most we could have is 2, because P could never go on Monday, and here we don't have any but 1. So we could have 2 there, but let's look at on Tuesday, for example, we could have O, P, and S here, so that wouldn't help us. And then on Wednesday, you could have an additional, on Wednesday, if you have a P and S here, you could have an additional O right here. So if that can't happen, you could have an additional O right here and O right here. So the only day where the most you can have is 2 is actually on Monday. So the correct answer to the question is A. 15, if the first batch of peanut butter cookies is made on Tuesday, then each of the following could be true except. All right, so if you look at this, my first batch of peanut butter is on Tuesday on 1, 2, 3, 5, 6, 7, and 9, 10, and 11. So we're really just blowing off the bottom scenarios here, and we're looking at these top 3 of each one. So each of the following could be true except 2 different kinds of cookies have their first batch made on Monday. Well, that could be true here. B, 2 different kinds of cookies have their first batch made up on Tuesday. Well, we know that we would have to have O going, one of these guys going first here. the question would be, could we ever get a P and an S being made on Tuesday? And it happens right here. We have two different kinds of cookies having their first batch made on Tuesday. Okay, just because there's a third cookie there with its second batch doesn't mean that it's dispositive to B. B just says two different kinds of cookies have their first batch made up on Tuesday. And it happens again in 5, 6, 7 scenarios. All right, if we look at C, two different kinds of cookies have their second batch made on Wednesday. Well, I have the second batch of P here, but no S. Second batch of P here, but no S. And this is the first batch of S, all right, so that can't happen. And my first batch of S is here. So I never have two batches of their two different kinds of cookies having their second batch on Wednesday. That simply cannot occur. I could have, my second batch on S is going to occur on Thursday, if I'm just looking at this intuitively. So S would automatically be out. And then O and P will never be the same as one another because O is always going to have a batch ahead of P. So again, the answer to the question is C. D, two different kinds of cookies have their second batch made on Thursday. Okay, well here, let's see, we have our second batch made on Thursday of P and of S, so that works. And then two different kinds of cookies have their third batch made on Thursday or on Friday, and it could happen again in the same scenario. So we know that the answer to the question is C. 16, if no batch of cookies is made on Wednesday, then which one of the following must be true? Well, if we look through our list that we made here, it can happen in scenario 7, and it can also happen in scenario 3. So we're looking at 3 and 7 here. So which one of the following must be true? Exactly 3 batches of cookies are made on Tuesday. Well, it could be 2, so it doesn't have to be 3. Exactly 3 batches of cookies are made on Friday. It only has to be 2. It could be 3, so that's not the answer. C, at least 2 batches of cookies are made on Monday. Well, we could only have 1 on this particular situation. And then D, at least 2 batches of cookies are made on Thursday. Absolutely. You have to have P and S both made on Thursday. That's the answer to the question, which is D. And then let's look at E, though. Fewer batches of cookies are made on Monday than on Tuesday. Well, here it's equal. Monday and Tuesday are equal, so that's not a must be true. So again, we know that the answer to the question is D. 17, if the number of batches made on Friday is exactly 1, then which one of the following could be true? So where do we have that happening? It really only occurs in 1, 5, and 9. And as long as we remember that O must occur sometime before Friday. So which one of the following could be true? The first batch of sugar cookies is made on Monday. Absolutely, that could be true right here. That's the answer to the question. Let's keep going, though. The first batch of oatmeal cookies is made on Tuesday, and that cannot happen. The second batch is made on Tuesday on all of these, so that will not work. If we look at C, the third batch of oatmeal cookies is made on Friday. If that were the case, we'd end up with O and an S, and we need S on Friday because we know that S is on Thursday, so that cannot be true. D, the first batch of peanut butter cookies is made on Wednesday. Peanut butter cookies always are made on Tuesday if S is to be the only variable on Friday, so that can't be either. And then E, the second batch of peanut butter cookies is made on Tuesday. Well, we should know that that can't occur anyways because peanut butter can never go on the first day because O has to occur before the first P. So again, the answer to the question is A. 18. If one kind of cookies first batch is made on the same day as another kind of cookies third batch, then which one of the following could be false? Okay, well, let's take a look at that. If you look here, the third batch, okay, and I'm just going to write into this now, okay? The third batch of O is made on the first batch, made when the first batch of S is occurring. Here, same thing. Okay? Here, the same thing could occur also. All right? This is the only time this can occur in all of these scenarios, and the reason why is it requires that S be moved all the way to Wednesday so O can fill itself in. It doesn't work on 12 because here, when we're exhausting the situation out with O, we have O skipping right here. So it only happens in these three scenarios, 9, 10, and 11. So it asks us which one of the following could be false. At least one batch of cookies is made on each of the 5 days, and that's absolutely must be true. They each day takes at least one cookie. B, at least 2 batches of cookies are made on Wednesday. Well, here we have 3 being made, 2 being made, and 3 being made, so that's another must be true. So that can't be the answer. C, exactly 1 batch of cookie is made on Monday, and that's exactly right. That's a must be true as well. D, exactly 2 batches of cookies are made on Tuesday. Again, that's a must be true. We have to have 2 batches on each of those scenarios. And then E, exactly 1 batch of cookies is made on Friday. Well, that could be false because in 10 and 11, we have 2 batches of cookies being made. Okay, that concludes Logic Game 3, LSAT 42, December of 2003. Thank you.